Okay, so how did the homework go? Not too bad. Okay, so let's go ahead and we'll solve the homework first. So last time what we kind of did is we're even though we're learning programming, we're kind of approaching it from not worrying about too many of the details at first, but kind of providing you with some tools, and then saying, okay, now go and try to solve some problems with the tools that you have. As we progress through things, we'll learn a little bit more about the tools that we have sitting in front of us, and we're going to talk some about strings today specifically, and some of the interesting things we can go do with strings. But for right now, we have a couple of things in our pocket, right? We know how to remember some things, so we figured out how to define variables and reference them. We know how to ask some questions with our conditionals or if statements, and we know how to loop through some stuff, right? So for the homework, we were supposed to loop through all the numbers between, what, 1 and a million? And each time through, we are supposed to ask a question. We're supposed to ask whether that current number is evenly divisible by, what was it, 9, 13, 27, 81. Okay, if it's evenly divisible by any of those guys, okay, any of them, then we're going to increment a count. So ultimately, the problem we're solving is we are counting the number of numbers between 1 and a million that are evenly divisible by at least one of those four values. Okay? So we're kind of taking all the tools we have in our toolbox, and it's a simple enough problem for us to wrap our mind around, but we're trying to solve it using the tools we have available to us. All right? So let's go ahead and let's clear out the code here. So we know we're going to need a count. Okay, and we'll start that guy off at 0 because we haven't found any numbers yet. All right. We know we're going to have to count through all the numbers between. Oh, can we see it okay? All right, so,
what's this called?
This is called Atom. Is that what you're talking about? The text editor?
Yeah.
Yeah, this is called the Atom text editor. It's nothing to do with Python, just a text editor for programmers. There's plenty of other ones that are good. This is the one that I went ahead and downloaded in class. It's kind of the current popular one. But this is no different than using text editor or something like that on a Mac or Notepad on a PC. It just does some color coding stuff for us and makes it look a little bit prettier. It's not doing anything special that makes it work. ATOM. This word right here. All right. So we'll start our count. Now we're going to write our for loop, and our for loop is going to go through all the numbers between 1 and 1 million, and we looked at the range function last time that kind of generated that list of values. So we'll say for I in range 1 to, actually we need to do that at 1, right? Because it's non-inclusive. So this will be from 1 to 1 million, not including 1 million and 1. Okay, so each time through this loop, I is going to be a value between 1 and 1 million. And we'll go ahead and prove that to ourselves real quick. We'll just print out the current value of I just to kind of give ourselves some confirmation that this for loop is indeed going through 1 million times and taking I on a little voyage between 1 and 1 million. Okay, we're not asking any questions about I yet. We're just spitting it out. I'll come out here to my terminal. All right, so I need to move into the same directory where that guy currently lives. I have it stored on my desktop. So on my machine, and actually I showed somebody a trick the other day. Let me show that to you real quick because it does work on, where's my terminal? This kid?
Yeah.
Oh, that's one of the kids I tutor. He's from Pennsylvania.
Online course?
Huh?
Online course?
Not an online course. Through my consulting business, I'm teaching him iOS programming. Let's see. Oh, this is it, right? All right, so I'll move that guy over to desktop 2 just so you can see it. So this is a trick you can do. Here's my file right here. Now, one thing I'd encourage you to do is get comfortable, working through your directory structure. So out here, I'm on a Unix system here. I'm on the Mac. So instead of it being the C prompt, my home directory is the front slash on Unix. So and right now I'm in front slash probably mlitman or something like that. Yeah, users mlitman. So that's my home directory. this right here is equivalent to the C drive on your Windows machine, right? So whether you're on Windows or Mac, I'd encourage you to go through some sort of online tutorial or something like that, and make sure you're kind of familiar walking through your directory structure from the command line. All right, I spoke to the 150 and 175 teachers yesterday. I think they're going to start including that in there. It's probably something that should have been included, but hadn't been something previously that we ran into issues with, because historically we've used a tool in here called Game Salad, which is all like drag and drop stuff. So you never had to do this kind of stuff, but this is a very important skill in computer science. So, but I'm going to show you a shortcut in the meantime to make life a little bit easier. But the punchline here is ultimately what you want to do is you need to move yourself into the directory where your file lives, so that when you type dir on Windows or you type ls on the Mac or a Unix machine, you see your file sitting there. So for me, that's going to be on the desktop. So now when I type in ls, I see a bunch of files, and one of them is test.py. So I know I'm sitting in that directory. All right. Now, one thing you can do though as a quick shortcut, so I'll move myself back to the base directory. So right now I'm not in the directory that has my test.py in it. You can type cd. This is the exact same command on Windows as well. So type cd and put a space. Make sure you're sitting in a place where maybe you have access to your visual files over here. I'm just going to take that test.py, I'm going to drag it into this window. I'm going to let go of it. And it gives me the full path to that file. Now, I actually can't change directories into a file. I can only change directories into a directory. So I do need to backspace the very end of that, just so it goes to the directory where that file ultimately lived. And then I can press enter, and now I'm there. That makes sense? So some of you were struggling with that. That's maybe a temporary way to, hey, I say it's a temporary way. I might use that way fairly often as well, but I would allow yourself to gain the skill set of being able to manipulate, work through the directories from the command line. 10 years ago, that was something that everybody could do who used computers. Now, the reality is today, everything is so graphical that we're so used to just double-clicking on folders and going, and everything's visual, right? How many of you, before this class, had never even gone out to DOS and done anything? Several people, right? Okay, that would have never been a truth in the past. Okay, everything is so automated for us that it's just the facts of life today, right? Okay, but as computer science folks, we still need to kind of operate in the historical side of things. And how many of you are IT majors in here? Okay, and the rest of you are computer science? Okay, so this is maybe even more important for the IT folks, where I think I mentioned the first week of class or something that it's often believed that IT means not programming. Now the reality is that as a computer science person, many of the tools that we use today are going to be graphical tools. We do all of our Java programming, for example, inside of here, I'll show you an iPhone project. So I'll open up an iPhone project. So the whole thing lives inside of Xcode. So, I have my source code files are in here. All that stuff lives there. Designing my interface is all inside of this storyboard. So I have all of my screens in here. So I do everything within this little environment. Now, every now and then, I do have to go out to the command line. There's a tool that we use called Cocoapods that allows us to install third-party applications into our project. So every now and then, I need to go out to the terminal and do something. But most of the time, and for many iOS developers, for example, you never have to leave this. Okay, so let's call that a computer science type skill set. And just as a quick pitch, we have our hackathon coming up. What is it, April 8th, I think? And then, so I would strongly, strongly, strongly encourage all of you to attend that. So that's going to be a Saturday, like 12-hour thing where we'll put you in groups. We'll put beginner people with advanced people, so you get to kind of go through a 12-hour write a mobile app that does something thing, and you'll hopefully learn a lot. I think it's the Tuesday before that, the 4th. I'm going to be running a boot camp that night for 4 hours where we'll come in And the first 2 hours will be iOS programming. The second 2 hours will be Android programming. And we're going to write 2 simple apps in those 2 different ecosystems. They don't do much, just kind of give you the basics, similar to what we did last class, where we know how to remember stuff, we know how to ask questions, we know how to do repetition. So I'll give you a couple of go-to moves in those ecosystems, but then we'll have them talk to a database that's in the cloud. Okay, so you'll kind of have, enough information to not feel like you're completely overwhelmed at the hackathon. I mean, it's going to be a learning experience at the hackathon. If you're a beginning programmer, the amount you'll be able to directly contribute is going to be limited, but there are going to be things that you can do, and you're going to learn a lot from that. So I would strongly encourage you to save the date, ask the day off for work, whatever, that kind of stuff, because you'll be missing an opportunity if you don't go to that thing. April 8th from 8 a.m. to 8 p.m. And we'll feed you a couple times. So you get
Saturday?
It's a Saturday. Yeah. And then the boot camp thing that's on the 4th is in the evening. I think it's 6 to 10 p.m. But I'm going to record that. So if for some reason you can't make that, you can just watch it sometime before the hackathon to kind of bring you up to speed. It's not required, but might be helpful just to kind of give you an introduction to some of those tools. Okay, but anyways, the point I was making here is if you're a computer science person, especially writing native applications, whether if it's iOS stuff, Android stuff, Windows stuff, you might not have to go out to the command line and do stuff that often. It's kind of what's called a once in a blue moon type thing. Now, web developers are going to be more like the IT folks. They're going to be working on a command line a lot. And the reason for this is whether you're an IT person who's set up a switch across campus, for example, you're not going to crawl down into some floorboard somewhere and sit there at a little keyboard and terminal to work on that switch. You're going to be sitting in an office over here remoting into that switch, and it's not going to look like a pretty desktop like this. It's going to look like this. You're going to be sitting at a terminal screen like this. So all the stuff you're going to be doing is going to have to be this skill set. Okay. Similarly, if you're a web developer, while you might be spending most of your time when you're doing development inside of a tool like this, when you go and run it and stuff, you might be out at the command line. But at the very least, when you actually finally say, okay, my website is done, and you need to put it out there on the internet somewhere for somebody else to access it, so the rest of the world can see it, not just you on your laptop, that's going to be remoting into another machine, manipulating stuff. A popular tool today for hosting web type stuff is a site called Heroku, which it's free, allows you to use a lot of the cooler, newer technologies like Node.js, those things. But everything you do with Heroku is all command line, 100% command line. So this skill set is very much a modern necessity for computer science folks. Okay, but it is kind of a lost art for people using computers in general because we like double clicking on icons and making things just kind of work. Does that make some sense? All right, so let's go ahead and test this. So I've made sure I've gotten to my directory where this guy lives one way or another. So on a PC, you'll type in dir. On a Mac or a Unix machine, you'll type in ls. That gives you the directory listing. And somewhere in there, you should see your file. As long as you see that there, you're sitting in the right place. You're inside the right folder. So now I'll go ahead and I'll say Python 3 test py. And it goes through and it prints out my 1 to 1 million values. Okay, so I've kind of confirmed for myself that I'm going through all of those numbers. And I think I mentioned last time the reason that it prints so slowly isn't because Python is slow, but because printing stuff to the screen is actually a complex thing. I did mention that last time, right? Okay, so there's a lot of the CPU works a little bit, then has to pass it off to somebody else to print it, then works a little bit more, and then passes off to somebody else to print it. So it's a pretty intensive operation. If I were to make this so it ran for a lot longer period of time, let's say I tried to do it to like 100 billion or something like that, after several seconds, you would feel, actually I feel it now, my computer's warm. Okay, because I mean it's working. It's going to feel like you're playing a video game in terms of the how much work your computer is doing. All right. So I see my loop taking me through 1 to 1 million. Great. So I'll go ahead and switch back to Adam. Now, we don't want to just print stuff. We want to ask some questions each time through there. We want to ask the question, is the current value of I evenly divisible by 9, 13? I'll have you give me the numbers here in a second again because I'll forget them again. But so we're going to ask the question if I is evenly divisible by 4 different numbers, right? And the way we do that is we look at the remainders. If the remainder is 0, it is evenly divisible. If the remainder is something other than 0, it's not. All right? So we'll go ahead and start our if statement. I'll put my parentheses on there, even though it's not required in Python. I think you should always put them in there. And this is going to be our Boolean expression that we're going to put in here. What's a Boolean expression? Any expression that boils down to a single value of true or false. That will be ingrained in your soul by the end of the semester, that little saying. And so I have a couple of like little mantras like that you'll be learning as we go through things. And it's very important that you end up remembering those things, but it's not going to happen through just trying to memorize it. You know, it's going to be one of those things where I'll say it and you'll just be like, any expression that boils down to a single value of true or false. Or finally, you know, you take the shortcut, you just say it's true or false. That's okay as well, as long as you fill in the gaps. All right, so if we're going to start asking our questions, this has to be a Boolean expression. This could be anything that boils down to a single value of true or false, no matter how scary it might look, right? So we looked last time, we saw that we can build, you know, complex-looking Boolean expressions that ultimately do boil down to a single value of true or false. So that's where we need to kind of get that skill set of slowing our minds down and asking ourselves, what does this line resolve to? What does it ultimately become after all the variables get resolved and all the Boolean operators get resolved and all that stuff? So what we want to say is the current value of I, when divided by, what was our first value, 13? 9. When divided by 9, has a remainder of 0. Okay, so if I divided by 9 is equal to, if I divided by 9 has a remainder of 0, that means that 9 went into I an even number of times. It's evenly divisible by 9. Now, that's not the only one we're testing. We're also saying, or I mod 13 is equal to 0. What was the next one, 27? Or I mod 27 is equal to 0. Or 81, I mod 81 is equal to 0. If any of those things are true, if this is true, or this is true, or this is true, or this is true, only one of them has to be true in order for the whole thing to be true. But if all of them are true or a couple of them are true, that's fine too. But only one of them has to be true for this entire Boolean expression to boil down to true because we're dealing with ors. So if at least one of those is true, we're going to say count is equal to count plus 1. And then in the end, we'll print out count. Now remember, in Python, indentation is very important. So this is very different than that and that. If I have print right here, it's associated with this for loop. And it's going to print, it's going to update me on count every single time through the loop. I'll still get my final correct answer, because that'll just be the last time it printed. But as it stands right now, this print is indented under this for loop. So it's going to print out count a maximum of 1,000,000 times, but we happen to know that inside this, we're only going to, actually, this will print out count literally 1,000,000 times, because it's underneath the for loop. If I put it underneath the if statement, it'll only print out when we increment count. All right, so if you want to see that, since print belongs to this if statement here, when this Boolean expression is true, we'll increment count, and then we'll print out count, but only under those circumstances. So this should print out count the same number of times as we found numbers that were evenly divisible by one of those 4 numbers. That's the OR operator, isn't it?
It's just a word at one.
That's not how I taught it, is it? So Python 2.7. Yeah. Nobody asked me about it. I would have figured that out. So yeah, Python 2.7 is the double thing like that. So 3 is that order. All right, so there's all the values that we went through that ultimately, so this should be our final answer, this last guy there. So that's if we're only printing when we get inside this if statement. If I move that print so that it's equal with the if statement, so it's indented under, it will happen every single time through the for loop, regardless of whether we got into this if statement or not. Because that print statement now no longer belongs to the if statement. It belongs to the for loop. All right, so we'll get the same final answer, but we're going to have a million prints. Okay? Now, realistically, what we're looking for is just the final answer. We don't need an update as we go through, right? So for that, we'll move the print so that it's underneath the equal with the for loop, which means it's part of the main program for us right now, which means it's only going to happen after this for loop has completed. So we'll see a single print in this case. And you'll see that this guy will run substantially quicker because it's not having to do all those prints. That makes sense? Okay, so questions about that guy.
What's the double equal?
This is the equivalence operator. This should not work. Let's just confirm before I promise you that that's the case. Yeah, that does not work. So the single equal sign is the assignment operator. We use that to assign a value to a variable. So count equals 0. Double equal sign is our Boolean, and we talked about those last time, the arithmetic Boolean operators, less than, greater than, all those guys. This guy says, is this value, the result of taking I divided by 27 and looking at the remainder, is that guy equivalent to 0? That make sense?
Yeah. It's pieces.
Bits and pieces. Tell me more about that.
All the other terms I'm trying to remember.
Okay. What I'd encourage you to do is don't try to memorize them. Give yourself your little cheat sheet, so think about it like it's a toolbox. Okay, so at any point in time, you're going to say, here's the things that are in my toolbox. Which tool do I need to pull out of the toolbox next to solve the problem I'm currently doing? Don't try to search for it in your head yet, because you haven't used it enough time. You haven't used this enough times to, I guess, just have it available to you. Does that make some sense? So keep a running list of the current tools you have in your toolbox, and kind of know every single time you go back to Home Depot, you end up buying something. And you come home and you throw something new into your toolbox. All right, so here's our tool of creating a variable. Here's our tool of doing some repetition. Here's our tool of asking a question. Here's our tool of updating a variable. It's just like creating a variable, but we're giving it a new value. We're assigning it a new value. And then we also already knew how to print some stuff. So those, this is solved in terms of all the tools we had available to us at the time. Make sense? All right, so I'll go ahead and I'll paste this code into Slack so you have access to this. Actually, this is just, we'll just do homework solution. Okay. All right, so now what we want to do is we want to run back over to Home Depot and do a bit more shopping. All right, so we kind of have numbers down, let's say. We already kind of had numbers down when we came in here to the class, right? We already kind of know how to count and that kind of stuff. We were already introduced to the whole less than stuff, greater than stuff, even equal stuff. I mean, whether we just have to get used to the double equal sign for equivalence. That's okay. But we still understood the concept of saying, is this guy equivalent to something else? That's something we've done for years and years and years, right? Now we're kind of putting it together to solve things in a little bit different way than we've done before. We've had math classes where we've done similar stuff to this. We just didn't think about it in terms of this. But I'm almost encouraging you to, at this point right now, think about this the way you think about things in math classes, where you don't end up actually appreciating your math stuff until years later, when you actually care about why something works a certain way. When you're in your math classes, when you're in school, most of the time it's about, what's the trick to get the right answer for this one? Each question is like a little puzzle, right? You solve that puzzle, you get your points on the exam, and you move on with life. Every now and then you get a student who's very interested in math who actually cares about why it works. But generally speaking, it's all about like puzzle solving. And right now, that's kind of what we're doing. You walk into like the Cracker Barrel, and the Cracker Barrel up in the store they have in the front, they have those like different, like the horseshoe things, little puzzles. You sit there and screw with it while you're waiting for them to seat you. And you're trying to figure out how do you get the two horseshoes separated because they're in like the weird chain puzzle. You know what I'm talking about? Yeah. Okay. So, it's that kind of thing. We have some tools sitting in front of us, and then I've given you kind of a word problem, kind of like in your math class, and now that's the puzzle you're trying to solve in terms of the tools that you have. All right, so what we're going to do here is we're going to go ahead and we're going to create a string hello. And we want to learn about some of the things we can do with strings, okay, some of the functions that can operate on strings. Now, we can do something like, so let me show you one thing. We can say that, hey, I might want to go through and I might want to access each individual bucket of that string. I might want to see the H, then the E, then the L, then the L, then the O. So we can write a for loop, something that repeats through something. But our typical for loop, we've said for I in a range, 0 to 100, let's say, something like that. That's what we've written to this point. Well, what happens over here? This function range creates a collection of numbers. That is all the numbers between 0 and 99 inclusive. All right? That's what gets created. So what we're saying is for I in each of those values in that range. What we can do is we can replace this range with a new range of values. That is the range we already have called S. S is a collection of characters, isn't it? We happen to have 5 characters in here. So I could say for I in S, print I. Something like that. So that'll get me the H, then the E, then the L, then the L, then the O. Okay, and we haven't done anything new there. We just gave ourselves some meaning as to what that thing that comes after the word in is. It's a collection of stuff. Before, we were using the range function to generate a collection of numbers. In this case, I've provided it a collection of characters. Make sense? So we can loop through all those guys. All right. So now, let's say that we wanted to only print out vowels. So things like A, E, I, O, U. Right? And we'll even keep this relatively simple and say, okay, well, we're only going to do this for the vowels that are lowercase, just to make our if statement a little bit more palatable. All right. So instead of just randomly printing out I here, we're going to ask a question. We only want to print out the lowercase vowels. Okay. So now I'm going to have to ask a question. I'm going to say if the character I'm currently looking at, and notice, let me just show you as an example. That variable does not need to be called I. I can call it whatever I want. So I'll call it C this time. Kind of character C for each element in S. So you can name that variable whatever you want. So now I'll ask the question, if C is equivalent to an A. Single quote, A, single quote, is the character representation of A. How do you think that that's different? How is this different than that? How are these two things different? What am I comparing? Go ahead.
In the second one, you're comparing the value of C to the value of a variable A.
Yeah, which I don't have here, but that's effectively what it's doing. So this is a char literal. Okay, so let's update our slides here. So if I say literal values, well, we have our numeric literals. Go ahead.
Can you make you can make like you can type things and not have it mess with your program in Python.
Oh, comments. How do you do comments?
Yeah.
I think in Python is it a
The pound sign.
oh this guy?
Yeah.
Yeah, there. So that's a single line comment. So this guy will be ignored. In most C languages, it's / for a single line comment. Multi-line comment in most C languages looks like that. And you put your comment 1, 2, 3, but you see that Python's not a big fan of that. So it's going to try to execute this line of code and say that doesn't look like Python to me. But this guy, just a comment, so you can say, maybe you're saying, ask if C is a val. That's what we're about to do there. All right, that's just as kind of for us to see as a human being. All right, so literal values. We have our numeric literals. We're already familiar with these. That's like things like 0, 1, 2, 3, 4 numbers. Okay, those don't change. Literals are, think of those as constants, things that are they just are. Okay, so literals are all of our numbers. Numeric literals rather. Then we have char literals. A char literal is a single quote followed by some char, followed by a single quote. So things like A, or question mark, or comma, or space. Those are all char literals when they have the single quotes around them. Then we have string literals. This is double quote followed by some string followed by double quote. These are things like hello, or the empty string, that is a string with no characters in it, no spaces. You could also have the string space. Understand the string space is different than the char space. Okay, the string space contains a single char, which is the char space. All right, but these are string literals. So those are our three kinds of literals. So anything that's not a numeric, that doesn't have single quotes around it, and that doesn't have double quotes around it, must be a variable name. For right now. Technically, it could be a method name later on, but for right now, must be a variable name. Go ahead.
So in Python, is there any big functional difference between a char space and a string space?
There is. You won't necessarily recognize it because you can use the double equal sign to compare them. But if you said is the char space, if you do something like this, is that equivalent to that, they're not. They're not equivalent to each other, even though as a human being, we know that this guy at bucket 0 is equivalent to this. So this string that has one character in it that happens to be the character space is equal to the literal character space. But they are different types. So this goes back to that whole idea of the type inference engine. And since this is a loosely typed language, if we play the role of the type inference engine here, we're going to say this guy is a char. This guy is a string. They're not of the same type to begin with. Does that make sense? Even though as a human being, we can look at these two and say, we know that at a certain level, these guys are similar. Okay, but they're not. It's like comparing, dog breeds or something like that. They might look the same, right? But this dog is of one breed, this dog is of another breed. But you know, when you get 12 inches of hair on them, they all just look like fur balls. Okay, so coming back over here, since this guy's not a number, and we don't see single quotes, and we don't see double quotes, it must be a variable name. And we don't have a variable defined up here named A. Okay, so this isn't being compared to anything. Does that make sense? So we actually want to compare the current character C to individual chars. So is C equal to A? Or E? Or I? See this again?
Write out or.
Oh, I do. Thank you. Or O. I'm just going to keep doing it. Or U. So this looks like a pretty similar question to what we had earlier when we were saying, is a certain number evenly divisible by 9 or 13 or 27 or 81? But now we're saying, is this value equivalent to this letter? Or is it equivalent to this character? Or is it equivalent to this character? So on and so forth. If it's equivalent to any of those guys, then we'll go ahead and let's just say we're going to print the vowels out. We're not counting them, we're just printing them. So we will then print out C. So this for loop goes through all the characters in S. So this would be Hello. Each time through, we pass the character kind of through a filter. We're asking a question about it. So if C is any one of these characters, then go ahead and print it. Otherwise, move on to the next time through the loop. That makes sense? So we would expect this guy to find a vowel here and a vowel here. So we should see EO as our output to this guy. Because HLL are going to fail this Boolean expression, which means we won't execute the code that's indented underneath the if statement. So we'll just loop back up to the next value in S. So there's our EO. That makes sense? So one thing we should start noticing here is we kind of have some like solution patterns that we're starting to notice. So even though we're saying different stuff inside of this if statement, it looks pretty similar to the stuff we said in a different if statement, right? Because Boolean expressions ultimately boil down to single values or true or false. So we're always going to be asking things inside of our questions that are kind of like this. Okay, you can think of it like a filter if you want, but you know, I've always advertised it as we're asking a question. If this is true, do this. Otherwise, don't. All right. I mean, if you want to throw an else in here, you know, we can say else print not val or something like that, just so you can see that it is going through multiple times. So for E and O, it'll print out the character. For HLL, it'll print out not val. So the output of this guy is going to be not val, then E, not val, then O. Because we chose to put an else in there. Forgot my colon. Not val E, not val O. Make sense? All right, so there's the if else. Again, we're practicing with that tool that's in our toolbox. All right, so this guy lets us spin through every character that's in a string. Now, we do have some potential problems here that's going to kind of lead us into our next homework assignment. So what I'll do is I'm going to go ahead and I'm going to paste this into Slack just so you have kind of a baseline for your homework. Although you're going to be solving, I'm going to challenge you to solve your homework differently than this. Although you can pull it off using this way. All right, but we want to look at a tool. So I'm going to show you where we went into Home Depot. We're shopping for power tools. And here's some built-in string methods, and we'll experiment with these a little bit. I'm only going to look at a certain one here first. All right, so let me show you length first. So I'm going to print the length. Well, here, I'll put it in a variable first. So we'll say numchars is equal to the length of s. And then I'll print out numchars. So the length of s should be 5. That is the number of characters that exist inside of the string s. Okay, so this guy, this function called length, takes a string as a parameter and he boils down to a number which represents the number of characters it found in there. So there's my 5. All right, so another tool to throw into your toolbox is the length. Now it does count spaces, so if I put some spaces in there, then do world and put a couple more spaces after that, the length is going to be, I don't want to count that, but larger than 5, but it's also going to count those spaces. So there's 19 spaces in that one. Okay? So there's one tool. Now we have this function here called find. Now, as you see, there's a bunch of functions in here, but I'm going to introduce them kind of one at a time. So ignore, even if you go and search for this guy, ignore those extra guys. I'm only going to when I give you assignments, I'm only going to give them to you with the expectation you're going to solve them in terms of the tools you already have. Even if you find a better tool, I want you to solve it using only the tools that you have. There's a reason to the madness, if you will. Okay? So the only other function I'm going to show you in here is this guy called find. All right, find is a function that takes in 3 different things. Let's see. All right, so let me show you how this guy works. I'll put this inside of a variable called find result. We didn't have to put it in a variable, but I'll do it anyways. In find result, we're going to call the find function. And the find function takes in 3 different parameters. It takes in a string we're looking for. It takes in the position of the beginning of the string that we're searching, and then it takes in the position of the last place we're looking for. So for hello, I'm going to say I want to search for example, maybe the string h. Inside of the string hello, which begins at 0, so the first bucket of that guy lives at bucket 0, and the last bucket is his length, 5, but it's actually 5 minus 1, which is 4. So when we look at this guy here, let me go back to hello so I can reference this appropriately. What's who? This is just it's a variable. I could have called this dog. Okay, these are just variable names. This string has 5 characters in it. This is bucket 0, bucket 1, bucket 2, bucket 3, bucket 4. So the legal buckets inside of S, inside that string, are 0 to its length minus 1. All right? So that's how strings are organized. That's also how arrays are going to be organized when we talk about them. And that's pretty common across all programming languages, is whenever we have collections of things, they're indexed from 0 to the number of elements in the collection minus 1. Okay? So find is going to have me searching for something here. So I'm going to pass in the string h, That's the guy I'm searching for. Then it wants me to pass in the beginning and the end. So begin is equal to 0. That's where I want it to start searching. End is going to be the length of S. That's where I want it to stop searching. And then I'm going to print out find results. Oh, doesn't like find. Oh my gosh. I don't think it's a function of that, but we can certainly try that. It would be S dot. Unless it is part of the string library and we haven't imported it. So let's try this, and then we'll try the other ones so you have the proper tool. Okay. So there exists a string class that has a function inside of it. Keyword arguments. Okay. It doesn't look like it has enough parameters to me. No. I'm thinking this wants me to pass it the string I'm searching for, and then beginning where I want to start searching, and then where I want to end searching. Let's try that. Okay, so give me an answer. Okay, there we go. Well, that was documented horribly in here, but I'll show you how it works. Let me just make sure this does what I think it does before I explain it. Yeah, okay. So string find is going to be another tool for us. This guy takes 4 parameters. It takes the string I am looking in. Then it takes the char I am looking for. Then it takes in the place I should start my search. Then it takes in the place I should end my search. So, for example, str.find, the string I'm looking in, hello, I'm looking for, let's say, an E. I want to start my search at position 0 in hello, and I'll end my search at the end of my string hello, which will be 5, non-inclusive. And what this guy is going to return for me, I'll put it down here. This guy, in this case, since I'm searching for an E, is going to return a 1. Bucket 1 is where it first found that E. That returns a 1 in this case. But the important thing, this is the power tool part of this, returns -1 if we do not find the value. Okay, so we went to Home Depot, we found this find function. So for our homework assignment, what we want to do is do something similar to what I have here, what I had here with the vowels, except I want you to print out all of the consonants in a string. Now you can write that with a zillion if statements, right? So if you want to put in, your 20 if statements, or your if statement with 20 ors in it to do it, you can. But I would strongly encourage you to write this code right here, which prints out all the vowels in a string. I would strongly encourage you to write the equivalent of that to print out all the consonants in a string using this new tool, this find tool. Okay? Make sense? All right, I will see everybody on Monday.